So we are at lecture number 2 for our subject, which is communication system. Very quickly, I will recapitulate the block diagram. Rather, yesterday's concept was block diagram of communication system. Okay, and in this block diagram, we said that we have some major blocks, which was the first one was info source. The second one was sender or source transducer. We discussed, I think, very thoroughly what a transducer can be. एक ट्रांसड्यूसर क्या चीज होता है? एग्जाम्पल हमने दी थी, आपने याद है कल? ट्रांसड्यूसर क्या होता है? Right, excellent. And when we specifically talked about communication, we said that we will have a transducer that converts our information into an electrical signal, and that signal needs to be sent either through an antenna or through a physical channel. Now, let's say for now we discuss the physical channel wala version, and then we said we'll have one more block, which will be the receiver transducer. Okay. And from there on, the information will finally reach the destination. Okay, we had given a brief idea about. Can you just tell me what we had gone through as of now? Now, when we talk about the channel also and brief idea of. Okay. We said for long distance communication, wireless communication. हमने पढ़ा है हल्की सी लाइन हमने लिखी that wired communication is generally preferred. Can you please prefer this location, please? आप थोड़ा left में जाइए. I told you yesterday only that I want students occupying the front benches, not the back benches, unnecessarily. इधर आओ जी, आप corner split please. इधर आओ to corner split. Hey, you stay at the corner. Because I want to make sure I don't forget that I have to change my dialect. Because if you're there in the back, I will forget. I will talk anything, right? So I want to see you very close to me. So we said wired communication will be preferred for short distance communication, whereas wireless communication is generally preferred for long distance communication. As a Q&A, maybe we will see that in later course of the journey. But for now, let's write the next block जो हमारा receiver transducer की छोटी सी function, because if a question comes जरा इसकी block diagram बताइए, उसको explain कीजिए. We should have at least one line definition for every block. So the receiver transducer, आप देखिए जरा, receiver transducer. We are writing about the third block, which is the receiver transducer. Okay, block number 3. Receiver transducer. Let's clear notes. Receiver. R-E-C-E-I-V-E-R. Receiver. Receiver. Not the receiver side. How about capital letter? So receiver transducer is the heading. It converts electrical signal. We know that the signal that we have sent into the channel is obviously an electrical signal. So your receiver transducer will actually convert the electrical signal into a physical equivalent. It will convert the electrical signal into a physical equivalent. Maybe it can be an image, so it will display an image on the screen. Okay? Into a physical signal equivalent. For example, the signal is a message. The physical equivalent will be through the loudspeaker. You can hear the voice. So then finally the destination can be the targeted location or a person for which the information was originated or transmitted through the channel. The destination can be क्या कहा मैंने? Targeted person or location or maybe device for which the destination के लिए. Destination will be the targeted location or a person or a device for which the information was transmitted through the channel. अच्छा, एक चीज मैं मिस कर गया कल के इसमें. वो प्लीज उस ब्लॉक, अच्छा आपने ब्लॉक डायग्राम वायरलेस की बना ली कि नहीं? अभी नहीं बनाई? चलिए हम अब बना लेते हैं। सो ब्लॉक डायग्राम ऑफ अ वायरलेस, block diagram, next heading would be block diagram of a wireless communication system. Very clear notes please. I know बनाइए, लेकिन एक चीज मिस कर दिया वहां पे. So same चीजें आएंगी वहां पे, information source transducer. मैंने यहाँ पे कहा डायरेक्ट एंटीना, लेकिन एंटीना से पहले एक इम्पोर्टेंट ब्लॉक आएगा जिसके बारे में ये सारा सब्जेक्ट है, which is called as the modulator. This modulator will send the signal to the antenna, which will send it in the free space. So it is the modulator. Eyes on board please. Eyes on board please. These two blocks are same. The only different block in a wireless communication system is the modulator just before the antenna and a demodulator just after the antenna from the receiver side. So we will have a demodulator block, and the demodulated will signal will go to the receiver. या अगर यहाँ पे बनाया तो देखते, ठीक है? यहाँ पे यहाँ इस तरह ये बनाया ना, इस तरह यहाँ एंटीना बना और उधर आप खड़ा demodulator बनाए होंगे। So it is this, eyes on board please. So it is this modulator that has the basics of the communication system subject that we are going through. Because when a signal comes, before sending it into the air, please eyes on board please. When a signal comes, before sending it through the antenna, I need to first modulate it. It is the modulation that is the key to communication that we see in the modern world, right? एक unmodulated signal अगर हम भेजने की कोशिश करेंगे शायद वो impractical बन जाएगा, ये चीज दिमाग में रखिए। एक unmodulated signal को अगर हम एक long distance पे भेजने की कोशिश करेंगे through antenna or through wire, if we try to send a signal, unmodulated signal. What is the unmodulated? Which is not modulated, okay? Where there is no action of modulation being done on the signal. Now, what is modulation? We'll see this secondly. So, it will be impractical to send that signal through this long distance. So, that is the reason we go for modulation. Okay, please keep this in mind. So, it is the modulation that helps us to send the signals to long distance, especially to send through antenna. तो आपको एक जवाब मिल गया है आम सवाल का, ये एंटीना किस लिए चाहिए? ठीक है, या ये मॉड्यूलेशन किस लिए है? मॉड्यूलेशन का पर्पस ये है कि आप उसको एक एंटीना के थ्रू ट्रांसमिट कर सकें। अगर आप मॉड्यूलेशन नहीं करेंगे तो मेरी एंटीना का साइज इतना बड़ा हो जाएगा कि उसको बनाना ही इम्पॉसिबल हो जाएगा। अब देखते हैं एंटीना का साइज छोटा सा इतना सा, आपकी उनका कितना कम होता है। So it is because of modulation. So you can just write one line. For transmission of signals to long distance via antennas, for transmission of signal to long distance via an antenna, for transmission of signal to long distance via an antenna into the free space, via an antenna into the free space, modulation has to be used. Modulation, फिर से बोलो, कहाँ से? बैठ पाओ। For transmission of signals to long distance via an antenna, हाँ? Right, via, V-I-A, via means through. For transmission of signals to long distance through antenna using free space, modulation has to be used. Modulation has to be used. That's the conclusion. Now, let's see if we do not modulate the signal, what will happen? Okay, that's an interesting question. Now, let's say, I commented this that if we do not modulate the signal, it will be impractical. That's what I have said. Now I need to defend my statement. So let me write the heading as Need for modulation. You all will write this. Need for modulation. This mod dot means modulation. What is the need for modulation, right? I need to understand this. कि हम modulation करते क्यों? मैं आपको ये कह रहा हूँ कि impractical हो जाएगा. जरा समझते हैं इसको कैसे impractical. Point number 1 is we do modulation. Point number 1, we perform modulation in order to reduce the antenna size. Point number 1, modulation is done to reduce the antenna size. इसका मतलब ये है कि हम unmodulated signal भी भेज सकते हैं एंटीना में. We can set unmodulated signals, but for that antenna has to be very huge. Maybe in order to send the signal for a distance of 10 kilometers, maybe a 9 kilometer antenna is used. Isn't it better than I go by foot and just drop the message 1 more kilometer? What is the fun of such an antenna which is transmitting message to 10 kilometers and the size of antenna is 9 kilometers? That is sheer useless. So, this is the property of an antenna. You can say the heading will be reducing antenna size. So the condition for faithful radiation of signals, we have a condition. We have a condition for faithful radiation of a signal. That is minimum the height of the antenna should be less than lambda by 4. Where minimum, that is जो minimum height हम use करेंगे, कम से कम height जो हम use करेंगे ना अपनी एंटीना में, ठीक? So वो होनी चाहिए lambda by 4. What is lambda? Right. Lambda is the wavelength of a particular wave. हम चाहते हैं कोई हम wave भेजना. We want to send a wave. We want to send a wave. What is a wave? Electronic signal. A wave is electronic signal actually. Because the varying nature of the electronic signal generates a wave signal. Okay? So if we want to send a wave, John, if we want to send a wave in the free space to an antenna, the antenna height, say for example we are using a Yagi Oda antenna. Do you know that antenna which used to be there back in say 95,000 antenna like this, it has so many, which you see on pictures, right? One single antenna and it has so many like strips, like a stair, but answering the stair. Have you seen that antenna? Yes, sir. Okay, that is a Yagi antenna. But let's say we have to use a certain height of that antenna. Okay, now the height of that antenna would be lambda by 4. Let's say lambda by 4 or less than lambda by 4. What is lambda? Lambda is the wavelength of the signal which we are transmitting. And this, there can be many components, like this wave will have many components, I mean various wavelengths, maybe it will change. But this lambda has to be related with the minimum frequency. The lambda which we will use here has to be the one which is associated with the minimum frequency component. Okay, I'll show you what I mean to say. I can understand you're not getting the point. Let me show you. Suppose this is an antenna and this is the height. And I know height of an antenna is say approximately equal to lambda by 4. And we know lambda is equal to mu by f. V by f, I mean say, where V is equal to C. C is the velocity of light. Okay. So what I mean to say is that as my frequency increases, What will happen to f? Lambda?
Decreases.
Decreases. So as my frequency increases, lambda decreases. Right? So that means for the higher values of f, my lambda will be low. For my lower values of f, my lambda will be high. I have to use the highest value of h, and that is obviously associated with the minimum value of frequency, right? I have to use the highest value of h, because as an engineer we design for the worst case scenario. We don't design for the best case scenario, right? We know a user is a user. Maybe a user has had a fight with his friend, so he will just use this mic. What is this? It has to be robust. This was not a good mic, I think so. It was not able to handle the pressure of a user. So we need to make things robust, and we need to make devices robust so that they handle any situation. That is called as designing for worst case scenario. Because when we design something for worst case scenario, it will obviously work for the best case scenario. But if we design something for the best case, maybe that will never exist. So we have to always prepare and design for worst case scenario. Okay. So having said this, this means that the lambda here which I'll be using has to be of the highest value. Okay. Next point. Lambda आपने देखा? Now transmitting antenna, this transmitting antenna converts to an electrical signal into EM signal. Did you write this point? This transmitting antenna, let's suppose this is an antenna, converts electrical signals into EM signals. And these EM signals will travel with the speed of light. The antenna converts the electrical signals into EM signals, electromagnetic signals. So मैंने ये कहा कि एंटीना का काम है रेडिएट करना, राइट? इनटू और इट इज अ काइंड ऑफ कन्वर्टर, या ये भी किसी में ट्रांसड्यूसर ही है, ठीक है ना? ये क्या करता है? हमारे सिग्नल को एक EM वेव देता है, और EM वेव हमें पता है EM वेव ट्रैवल्स एट स्पीड ऑफ लाइट। इलेक्ट्रोमैग्नेटिक वेव्स। Next one, EM waves travel at speed of light. ठीक है? ये एक fun fact बन गया आपके लिए। EM waves travel at
Speed of light.
speed of light, that is c. Now I have classified an expression for antenna height. So if I just now is this expression correct? Please have a look. H is equal to, say I am saying now let's be equal. We are using an average version, not the lesser one. H is equal to, let's assume H is equal to lambda by 4. We know lambda is equal to C by F. कहाँ से पता चला यहाँ से? Lambda is equal to C by F, and therefore your antenna height H is equal to C4 into F. अब देखिए, आप समझिए क्या मसला है। Modulation is basically, आप देखिए जरा, modulation is basically is a process of increasing the signal frequency. Modulation is the process of increasing the signal frequency modulation जो हम करते हैं, उसमें main मकसद, this is not a formal definition. This definition is not a formal definition of modulation. We will have one more definition of modulation later on, but just to give you an idea of what modulation is. So in a modulation, mechanism, or while we are modulating a signal, if my frequency of the signal originally was say f1, नहीं समझ नहीं आया क्या? Okay, very good question. But I'm not talking about this equation. मैं equation की बात नहीं कर रहा हूँ. अच्छा क्वेश्चन है, लेकिन equation को आप छोड़ो साइड में. मैं जनरली कह रहा हूँ. Definition of modulation is मेरे पास f1 की कोई frequency, मैं इसको एक modulator में डालता हूँ. Modulator block. इसका काम है ये फ्रीक्वेंसी को बढ़ाता है. वो कैसे बढ़ाता है वही इस सब्जेक्ट का काम है, वही हमें इस पूरे सब्जेक्ट में सीखना है. ठीक है? This is a good question, but that is what the subject is about. How to do modulation? What are the different ways of doing modulation? By modulation I mean frequency increasing. So ये f1 से convert करता है इसको into f2, and f2 is greater than f1. Okay? Now let me use this in this expression. So my h1, while I use f1, okay, and another is h2 while I use f2. देखा सबने? Eyes on board please. I have two expressions. One is जहां पे मैंने f1 को use किया. Eyes on board. मैंने f1. Anybody has to come on board and write the answer. I have a question for you now. So listen to me first. I have generated two frequencies f1 and another frequency f2. मैंने कहां से जनरेट की? मैंने एक मॉड्यूलेटर ब्लॉक को दिया. ये मॉड्यूलेटर ब्लॉक का काम क्या है? फ्रीक्वेंसी इंक्रीज करना. इसने सिग्नल का नेचर, the modulator kept the nature of the signal as it is, but it just increased the frequency. Please keep in mind, a modulator does not change the nature of the signal. If it is a cosine signal, it will remain a cosine signal for time being. If it is a noise signal, it will remain a noise signal. It just translates the frequency, or I would say it just increases the frequency. I have a frequency f1. Say this was a song which I had a frequency f1. I translated it to a frequency f2. The song still remains the same. The nature, the voices, but its frequency just gets changed. Now what is the advantage? That we have to see. This f1, when I use this expression in f1, it will generate a value h1, right? When I use this value f2 in this expression, general expression, this is the general expression, it will generate a value h2. Now is the question. I have h2 dash 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 h1. Wait. आ जरा आप ब्लैक हाँ आप ही आप जल्दी से दौड़. Can you tell me what will be the relation between these two? शाबाश. एक्सप्रेशन सामने सोच थोड़ा देखो. वन से क्या रिलेशन है? Okay, any idea? Huh? f1 should lesser value. You should suppose you should 2. You should 4. Huh? Means is constant. So something divided by 2. Something divided by 4. छोटा कौन होगा? h2. इसको 4 से डिवाइड करते हैं. h2 छोटा होगा. देखो एक्सप्रेशन को क्या है यहाँ? h2 बड़ा होगा कि छोटा होगा? फिर क्या ही है? साइन क्या है? इस बड़े कि इस बड़े? हाँ, शाबाश. आज फिल द ब्लैंक टाइप में सब मुश्किल. एक बार बचा. Okay, you can go. Thank you. Say. So h2 is smaller than h1, but actually it will be very smaller, right? And that is what was needed. Because what I was trying to do is that I had an antenna which was extending to 9 kilometers. Now maybe I made an antenna which is extending just 9 meters. Isn't that good? Why is it possible? It is possible only because of modulation. So just to elaborate on this example, let's say, Jaguar. Take a deep breath. And maybe some water. You should bring some water bottles with you. Okay. Now just write. I won't talk, you just write. So I have a question or example, or you can say just example. Is it visible by the way? Is it visible? Yes. How visible is it? My God. Okay. So, example I have for you. The example is, I have an unmodulated signal with frequency equal to 15 kilohertz. Find h of t. What is ht? Height of antenna. Can you just find it, please? Kilohertz, by the way, means 10 is for 3, huh? In my language, it is 5 kilometers. I don't know what about you. So this is say question number 1, for example, A part. B part is, if we send this 15 kilohertz to a modulator, it will generate a frequency of 1 megahertz. So, B part में modulated signal frequency is equal to 1 megahertz now. Can you tell me what is the antenna height? HT. The expression remains same. हाँ आपसे मैं पूछूंगा आपसे अभी मैं वहाँ आ रहा हूँ. Yes you. You should do it correct now. मुझे HT का वैल्यू बताओ जल्दी से.
75.
आपसे नहीं पूछा. HT 3 into 10 raised to power 8 divided by 4 into 10 raised to power 6. For you, megahertz is 10 raised to power 6, huh? Kilo go 10 raised to power 3, mega go 10 raised to power 6. 0.5. This is a huge difference, right? Can we see the difference? हमारे पास जो है एंटीना लगता है. फिर हमने कहा हमें इसी 15 किलोहर्ट्ज को मॉड्यूलेशन की और उसमें इसको फ्रीक्वेंसी ट्रांसलेट किया टू 1 मेगाहर्ट्ज. नेचर ऑफ द सिग्नल इज सेम, एवरीथिंग इज सेम, जस्ट उसकी फ्रीक्वेंसी चेंज हो गई. फ्रीक्वेंसी चेंज करने से हमें एडवांटेज है कि हमारी एंटीना हाइट जो है वो रिड्यूस हो गई टू ओनली 75 मीटर्स. ओके, व्हिच इज स्टिल वेरी हाई. This is just to make you understand that by doing modulation, you are practically reducing the antenna size. Check here. Hey, Nendra Prasadan. Near Gaston, say it one. Hi. Second is,